Hello, it's Tina from Gasgoo. Welcome to our CTalk. Today we are going to have a conversation with Ali Kenny, Vice President of NVIDIA Automotive Division, and Liu Tong, General Manager of NVIDIA Auto Business in China. NVIDIA has always emphasized its high performance, focusing on the high-end markets while building ecological systems. In the self-driving race, NVIDIA does not build its own cars, but firmly stands in the leading position by building high-performance products platforms with extensive global ecosystems. NVIDIA's automotive business consists of infotainment, ADAS, and autonomous driving systems. Currently, infotainment systems and ADAS are the main source of revenue for the business, while autonomous driving systems are a big source of revenue growth for the future. Today, we will discuss about lots of topics, including autonomous vehicle development, automotive market trends, NVIDIA's automotive business and its product portfolio, as well as how AI empowers chips and autonomous driving. Let's wait and see. So we began with a very easy question at the beginning. So how do you define NVIDIA in auto industry? And what's the major business? Can you give us a brief introduction about that?
Yeah, so NVIDIA's strategy in automotive is to be an end-to-end provider of solutions for the automotive industry, from the computer in the car to the data collection system that would be able to capture data from the car, all the way up to the cloud, where we help our partners train the AI models that they're developing for their self-driving stack, or intelligent voice applications they may be developing inside the car, and also simulating and validating those systems in the car. And there's actually no company in the world who does all of those things across the platform, from the car all the way to the cloud. And that's our product strategy, and what makes us unique across the industry.
Specifically speaking, what's the major contribution of the field? I mean, for example, the entertainment, or have you ever divided in such kind of category?
What's our major contribution in the field for what? For automotive? Or?
Yeah, for automotive, of course.
Yeah, I mean, I think our biggest contribution is absolutely in the cloud for customers training their AI models and simulating their AI models. If you actually look at the top 30 automotive companies in the world, essentially all of them work with NVIDIA on their training solutions in the cloud. So we have a very strong leadership position there across anywhere across all the continents. But we also help customers in the car. People are building cockpit solutions, people are building self-driving solutions, and we also are helping them in that part of the stack for automotive.
Yeah. If we talk about the infotainment, the ADAS, as well as autonomous driving, what's the portion of that, and how do you view their growth trends in the future?
Yeah, the majority of our business is self-driving, but there's a lot of innovation. We come to this show, there's a lot of innovation in the car, in the cabin. It's not just driver monitoring, occupant monitoring. The way I see it is there's so many displays people are putting in the car, and there's so many rich applications these OEMs want to develop. It could be a video conferencing application, it could be an intelligent voice that can answer any question you have. And so I think there's going to be a lot of growth there. And NVIDIA is going to be investing to be really successful across both autonomous driving and in-cabin solutions.
So you've been in the Shanghai Auto Show 2023 already. What's the general impression, except what you just mentioned? Any other impression?
Yeah, I would say that this is the best show for automotive in the world. And it's because the innovation in automotive is being led by China. There's so many great OEMs building new energy vehicles and hybrid vehicles that are truly state-of-the-art in features, functionality, and range. Inside the car, the cabin experience, the amount of displays and the software inside those cars is quite a bit ahead of where we see anywhere else in the world. And then if you start testing these cars and you experience self-driving anywhere in the world, China is ahead of everywhere else. So I just think that the whole world needs to come to China and see the amazing innovation and technology that's being developed here, and everyone should learn from it because it's not just where they're at, but it's the speed of innovation in China is ahead of anywhere else in the world.
Yeah. Okay. So how about Mr. Liu? You are also in charge. You are in charge of China business, right? Automotive. So what's your impression about this Shanghai Auto Show?
那我说一下中文吧。就是上海 Auto Show，我是第2次参加。那我感觉这一次 Auto Show 就对比上一次的 Auto Show， 应该是3年前吧。已经有了一个非常大的变化，就是第一个感觉就是中国在电动汽车智能化的这个道路上，我们对比3年前有了一个非常大的飞跃。所以刚才阿里也讲了，我们中国的这个智能汽车应该是在引领全球的一个创新，这个是我们在 Auto Show 感受体会非常深的。所以当然我们公司在这个潮流当中肯定就是有更多的一个发挥余地了。
Can you briefly introduce NVIDIA's automotive China business right now?
NVIDIA 在汽车这个业务上边，在中国我们一直都是一个可以说是一个非常重要的阵地吧。阵地。对，我们在中国有非常多的主流车厂，包括新势力和传统车厂都在使用我们的自动驾驶芯片方案，当然也包括我们在数据中心端的这些解决方案。所以在整个英伟达公司来讲，在中国区我们的汽车业务都是非常非常重要的。当然我们也取得了不错的一个成果，在 Auto Show 上你可以看到很多车其实已经搭载了 Orin X， 就是我们 Orin 系列的这些解决方案的。
So Ali, are you satisfied with the performance right now in China?
Of NVIDIA's performance in China?
Yeah, sure. Automotive, I mean.
Yeah. So we're very proud of our automotive business in China. There are so many companies building exciting cars, from the traditional OEMs like BYD and SAIC and GAC, and then also a lot of these new energy vehicle startups have been created, NIO, Xiaopeng, Li Auto, and we're very fortunate that all of the companies that are building these really exciting self-driving cars, are partnering with us both in the car and in the cloud. So we're very excited about the work and also very proud of the accomplishments we've made in China.
What will be the major growth points in China for the next 3 years from your point of view?
So I think there's a couple things that's happening in China that'll create a growth opportunity. The first thing is cars are quickly being transformed. China is the largest auto market, and also it's the #1 place in the world where NEV adoption has been going up. The rest of the world, NEVs are less than 10% of the market. China actually has already hit 30% of their cars are NEVs. And so as NEVs increase in penetration, then software-defined vehicles become an opportunity in this market. And when you're building a software-defined vehicle, you build it differently than a traditional OEM. You want to build that car with the highest performing computer and best sensor set that you can, and you want to ship that vehicle. And then over time, you're going to create software and services that make that car better, even after the first day that it was purchased and driven off a lot. And so there's a lot of opportunities for us to help these Chinese companies that are building these software-defined vehicles in the car. But the second thing is all of these vehicles are moving up in the level of AI that they're putting in their cars. Today, the cars are level 2 cars. You're still in the vehicle, but over time, those cars will shift over to level 4. And the cockpit experience that we talked about is going to add a bunch more artificial intelligence to it, where the car will actually know everything about you and be able to dynamically adjust to who you are and what you like to do, answer your questions, book your hotel rooms and food. And so we can help customers there as well. As you go up the stack, also the infrastructure you need to support self-driving, simulation, training, those needs go up exponentially as well. And so we can help our customers there. So the combination of all those trends is going to create a big growth opportunity for us in China.
Yeah, it's really, really fantastic, right? For the automotive developments in future. And what kind of role China market play right now in the NVIDIA business globally?
I mean, I think what we see is China is leading in innovation. And so we love it because for us, what we start to realize is China is leading in innovation. And so we start to realize is let's listen more to what our China customers want, and let's build products for China. And why? Because their needs are more advanced, they're further ahead than what we see in other parts of the country. And so increasingly we think about what do our China customers need, what do they want, and we build products specific for that local China market.
So with the evolution of intelligent driving into the full autonomous driving, actually they will require more and more higher requirements of the chip design, right? Can you share your insights on this part?
Yeah. So the way, as you move to level 4, the way you architect your vehicle from computer all the way to sensor set to software needs to be designed with redundancy. And so you'll find customers today that have a single computer. They need a second computer because if the first computer fails, you want to have a failover computer. And then you want to build a car that has multiple sensor modalities. So you want camera, but you also will want a radar and or a LiDAR so that when you see something, it's not just one sensor that sees it, a second sensor also sees it, and only when two things agree do you actually make an action. That increases the safety of the product. And then the way you build your software stack on top, everything in that software stack from the operating system to the middleware to the application software also needs to be designed with that same level of redundancy and availability in the system. And only then can you actually trust a car to drive with you kind of not being in the seat. Like you could be asleep and you know the car will drive you safely because even if something goes wrong, the car can pull you over to a safe space on the shoulder of the road. And so you have to put all of those together. And so there's very few companies that can do this, and it requires not just know-how of software development in the car, but a combination of building cars and testing in the vehicles, but also simulating in a virtual digital twin of the car in simulation. And when you have all of those miles that are tested in simulation and in a car, then you can say, I really believe this is safe, and let my customer actually also try that out.
Yeah, when we talk about the autonomous driving, actually it seems a little slower than we used to expect. From your point of view, what's the major challenges we are facing now and how to improve them?
Yeah, I think the big challenge is that this is an application where lives are at stake. And so everyone in the industry needs to take extra care in how we make decisions, how do we write software, how do we test software, how do we architect our car, such that the entire system and the entire way we develop software is safe end-to-end from car to cloud. And so you don't actually want to go too fast in this. This is not the kind of thing where, well, let's just ship the car, say it's a level 4 system, and if something goes wrong, we'll fix it. You can't do that. And so you actually have to take care. You have to be extra careful. And it's good for the industry to actually do that, right? Like we don't want to do anything until we really know it's safe. And the best way to do that is really make sure you have a lot of miles on the road, a lot of miles in sim, and then only when you've proven yourself with real data that this is safer than how a human would drive, should you actually turn on that capability.
So it cannot be designed by human mind. You need the improvement of all technology takes time.
Yes.
Right? Another hot topic right now is the ChatGPT. People talk ChatGPT worldwide. Do you think the artificial intelligence will affect the chip design industry, and how?
Oh, absolutely. I mean, so for us, our entire business is about artificial intelligence. ChatGPT is one of the bigger drivers of NVIDIA's success right now. And we're seeing it revolutionize the way everything is done. I think it's going to be foundationally disruptive to the industry. Even in automotive right now, we have partners who are thinking about how to make your vehicle my ChatGPT. So imagine it's a BYD car, and the BYD car actually knows everything about you and knows everything about your car, and you can ask any question and the car can answer it for you or do it for you.
Wow.
And so it takes a lot of new innovation, but even that type of technology is very valuable in automotive.
How long will realize that scenario you just mentioned?
In the next few years. I mean, people are now already developing it, and so you'll see it in cars in the next few years.
So is it possible to design the chips with AI? I mean,
Yeah, so all of our chips that we use in automotive is foundationally about AI processing. And this is because everybody in the industry trains their AI models in the cloud on NVIDIA. They're using CUDA, they're using TensorRT. Every university, from Beijing University to Tsinghua University to Berkeley, Stanford, Harvard, Oxford, Cambridge, they're all teaching NVIDIA programming based on CUDA and TensorRT because it's easy to program. It's easy to test a new function and run your AI models in the cloud. And that same architecture in the cloud, the same APIs in the cloud is what we have in our SoCs, computers in the car. And so it makes it faster for our developer partners to train their models on NVIDIA hardware in their cloud service provider, and then also use the same models they trained on to inference in their cars.
So can you give some examples of the AI application specifically in just what you mentioned, especially the autonomous driving technology?
Yeah, so I mean, if we go to Shanghai Auto Show today, that you saw Xiaopeng and Li Auto and Neo Cars, and their self-driving cars, and their self-driving AI application is run on NVIDIA's computers in the car. And then all of the OEMs also are training their AI applications in the cloud. They're not, they're trained in the cloud, and they're all training on NVIDIA systems in the cloud.
Last year, NVIDIA actually announced the Thor chip with a computing power of up to 2,000 TOPS. Why would NVIDIA introduce such a high-powered chip, and how to achieve that?
I think this speaks to your question earlier today, where you said, why does it take so long to do self-driving? And it's because everything in the architecture of a car needs to be upgraded. The quality of the sensors need to be upgraded, the robustness of the operating system and the middleware, the simulation environment, but also the computer. Because these new models that are being developed require really high performance. The new sensors that are being created are higher resolution. So you need more performance to process a higher megapixel camera. And then, then you also want to have space to run shadow mode in these vehicles. So you want to be driving on one algorithm, but you want to be testing at the same time on another. And only when that algorithm in shadow mode proves it's safer than the one in the car would you then release it in the car. And so you need extra room, extra performance to be able to build a safe level 4 system. And so, we built Thor to be able to let you do that.
So whether the computing power of autonomous driving chips will be further improved in the future, follow this trend, I mean?
Yeah. I mean, you see that, we had Orin, and it was 250 TOPS, and we have Thor, which is 1,000 TOPS, can be scaled up to 2,000 TOPS. So I think you'll continue to see that trend because, we're nowhere near good enough to be true level 4. And so we'll need higher performing computers and cars to really get to L4.
Okay. As a vehicle, EE architecture actually is evolved from the distributed to the centralized. The intra-domain integration and the cross-domain integration become a general trend. How do you think about this trend? Yeah,
so I think that's a great trend. And the reason is it's really hard to program a car if you have 100 computers in it. And that was today's vehicles, like traditional vehicle architectures, have 80, 100 little chips in them. And so the problem with that is it's very hard to create new features and functions over the life of the car and to support programming that car safely and securely. And so if you centralize and you have a high performance computer and it centralizes all these functions, it's easier to program, it's safer, it's lower power, it's lower cost. And so there's so much advantages to centralizing the architecture. And that's why you see all of these new energy vehicles, they have that kind of architecture, and you'll see more and more cars transitioning to that architecture as cars get launched.
Yeah, how long will it be centralized? I mean, full realize that?
Yeah, I think it's already happening. So we're already seeing people who have centralized, and I think we'll just see as more and more partners will be centralizing. What we find today is there's centralization of, it used to be an NCAP computer, a parking computer, a driver monitoring computer, and then like your L2 plus computer. Now all of those are on one computer. So there's a level of centralization. But then now some of our partners are integrating some of the body and control functions that you have in a car, lowering your window, steering, that all still happens now in the main computer. And then now with Thor, some of our customers want to actually integrate the cockpit computer, the cabin computer in the ADAS computer. And so centralization has already happened, but there's more centralization possible where there's more computers that exist today that are separate that will be integrated into a single computer.
Chips are so important. We see even some OEMs, for example, the China OEMs, the Geely, the Auto, Xiaopeng, they have already entered the chip industry by themselves. What do you think of this phenomenon? Will they have some effects on the partnership with OEM and NVIDIA?
Yeah, so I think for us, the first thing to realize is our strategy is end-to-end. So if somebody uses us in the car or not, actually it doesn't matter because we're still a huge partner of them, training their systems in the cloud, in simulation. If you kind of look at our market share, we have essentially like 100% market share in the cloud. We have like less than 10% market share in the car. So if someone wants to build their own chips in the car, it doesn't have a major impact to NVIDIA because where we have our leadership is in the cloud. Now what I'll say is about building chips, once an application is defined and you can get in the car and you feel like this car is done, the software for this car is complete, the experience is great, then if you take your software stack that exists and you want to build like a dedicated silicon chip for it, I think that's a reasonable strategy because if you know what the software is, you can build dedicated silicon that can do it and maybe you save some money in it. But if the situation is that you're just at the beginning of innovation and you're barely at a good level 2 experience, and so you don't know what your algorithms should be, you don't know what the software should be, the only thing you know is you need to keep changing it and improving it to get to level 4. During that time, the most important thing is not like the cost of the chip, it's the efficiency of the developer experience to come up with these new models, train them. And so that's where it just makes sense to develop on CUDA and TensorRT, have the same APIs in the cloud in the car. Then your engineers are faster. The reason why China is so successful today is their engineering productivity is better than everywhere else. So it only makes sense to actually make these changes when you feel like your software is done. And so then you're just trying to cost it down. But if you want to maximize engineering productivity, which today in automotive, that's the case, we want to change so much, it doesn't make sense to build custom silicon. And why is that? Because by the time you get the chip, you want to change the model. And the chip isn't good for that model. You wanted a general purpose AI computer, and that would be CUDA and TensorRT at this stage in automotive.
So if they want to do this by themselves, there is a lot of new things how to learn.
That's right.
It takes time and it costs money, right?
That's right. That's right.
Okay. So NVIDIA also, we see that you have very wide range of customers from the traditional OEMs, the newcomers, international one, local one, as well as some cross-border enterprises. So what's the major differences between their customers' demands and services demands?
I think in this case, it's just more about each geography. The customers have a different kind of sensibility. In China, there's just an interest in really high performance cars that have great electronics and great software in them. And so our partners in China are building cars that are really rich in computer and software feature set. And then, in Europe, many of our OEMs are building really luxury cars. If you go inside them, it's just the craftsmanship inside them are incredibly beautiful, high quality. So it's a different type of customer base, and I think each of these customers are building it themselves. We have some partners in the US, their customers like trucks, and they have business customers. And so then you build a different kind of car for your customer base. And so for us, it's actually a good experience because everyone is different. And the challenge for us is how do we build an architecture strategy that makes sense for the entire industry.
Do you focus on certain kind of customers if you can select?
Yeah, no, I don't think we focus. We try to play with all players. It turns out that when a customer has a strategy of building a software-defined car that has really good self-driving capability or really advanced cabin functions, we're more successful with those partners. And I think we also feel the whole industry should be moving to that. We feel that's the right strategy because the revenue that you can generate for a car over the life of a car is a transformative business model for our automotive customers. And as these OEMs recognize that, they're shifting to this model, and that is better suited to our positioning and our advantages.
Okay. Maybe this question I should also invite Mr. Liu to join us, share your experience in China about the customers' differences. Please in Chinese.
OK， 我觉得在中国，我们进入汽车领域这些年，我是有切身体会，尤其是智能驾驶这个领域，我们国内的这些新势力也好，包括传统车企开始做电车的这些公司，都在智能驾驶这个领域充满着它的一个激情，也有非常清晰的一个发展路线。尤其是在过去这2-3年，我们的 Orange 系列的产品开始有机会进入到这些电动车，给这些车企带来了一个更强的计算力，也能让它有机会去开发出来更好的一个软件，去释放这种体验。所以经过这几年的一个开发经历呢，我是越来越有信心，我们有机会亲身体会到了很多家车企它的一个智能驾驶的这种方案。我们感觉到就是最新的这些自动驾驶的软件已经比以前好了非常多，所以在不久的将来，我相信越来越多的智能驾驶的汽车就会推向市场，我们大众都有机会体会到这个截然不同的用户体验，可能对比1-2年前说的这种自动驾驶会完全不一样，会颠覆我们对自动驾驶的一个认知。我还是觉得在今年下半年，用户体验真正的会为我们赢回来一种用户的信任。
那么刚刚讲在客户选择上，你们会有一些重点的倾向性吗？或者是有一些定向的方案吗？
您指的是车企？
对。
我们没有非常强的倾向性，我们是觉得在中国的这个电动化、智能化这个道路上，每个车企都非常的坚定，在朝着这个方向的发展。其实可能有的公司它的初期的投入是特别的大，有人选择渐进的这种路线，但是大家都对智能驾驶是抱着一种必须要做的这种态度，所以我们就像阿里也讲到了，我们提供的非常完整的一个解决方案，就是无论你的车企，你的一个战略思路是什么样子的，我们都有合适的方案可以去提供。回答你这个问题，我们没有倾向性，我们的解决方案可以适用于激进路线也好，或者是比较保守的路线也好，我们都可以去提供相应的技术支持。
Okay, thank you. So Ali just mentioned the SDV, software-defined vehicles. How's the progress right now about this field? And will SDV have some effects on the strategy and the product portfolio of NVIDIA?
I think we really only build products for people who are building software-defined vehicles. So for us, it's just more of reinforcing our strategy. And what we see is the industry is accelerating in this way. China is actually a leader in this industry, and I think other markets are learning from China, trying to catch up, and we'll see more and more SDV cars from OEMs outside of China soon.
Yeah, okay. So how NVIDIA define vehicles through software?
Well, we basically build computers that are very easy to program and very easy to build multiple applications at the same time, safely and securely on that one computer. And so when you have those two combinations, it is perfect for building a software-defined computer on top of.
That's your advantage
please.
also.
Thank you.
As we already know that Omniverse has been introduced already. How can simulation platform promote autonomous driving?
It's very hard to just test software in a car.
Yeah.
Because when you have a development fleet, you can't have millions of cars as your development fleet. You can just have, hundreds. But for self-driving, you need to make sure that your software is safe. So the only way to do that is have a real vehicle fleet but also have a simulated vehicle fleet. And so you want to be able to build a platform that's truly physically accurate and identical to the car. First, test your software in simulation in the car, in the virtual car, and do millions and millions of miles in sim. And then, that software is being tested when engineers are sleeping at night. And then in the morning, you take the software, you test it in the car in that loop, where you're going from simulation to the car, and you're updating the car that way, is how you get to a true safe vehicle in a fast time.
So it will increase the efficiency, very, very high efficiency.
Yeah, it increases the efficiency of developing self-driving software, and of course it increases your success of building true level 4 software.
From your point of view, what's the current limitations of the self-driving simulation testing?
I think it's just more about building up a platform that lets you test every part of a car's experience. So you need to have an environment model that is accurate to all the scenarios in the world, traffic simulation that's accurate to every scenario that you could hit with. And so how you get the scenarios to encompass everything you might come to the real world is a challenge. And what you do is you encounter things in the real world, and as soon as you encounter them and you realize you don't have that in simulation, you add those scenarios in simulation. And over time, your simulation environment is really, really extensive, and the breadth of your testing is essentially like everything you would come to the world. And I think that's really the challenge, and the industry just keeps better and better at that as we increase our testing in the field.
So you're also working on the breakthrough of these limitations already.
Yes.
As we see on the Shanghai Auto Show, the smart cockpit is really fancy, and it plays a really important role when people want to buy a car, test the car experience, the car. So what kind of trends in future from your point?
Yeah, so there's a couple things. So the first thing is there's a lot of artificial intelligence that we'll see in these cars. And so we're trying to help our partners develop those applications in the car. It could be artificial intelligence software that does driver monitoring. So let's say that you're driving and then you start to kind of fall asleep. So the algorithm can see that you're falling asleep, and we can alert you. Or maybe in the back seat, you might be leaving the car and maybe you left something. And so you can give alerts to the customer that something was left in the back seat. That's artificial intelligence software that is becoming more and more common inside the car. And then of course, the car needs to be, you want to ChatGPT your car. If something is wrong with the car, your car should be able to tell you exactly what it is and how to fix it. And so essentially you don't anymore need to have a manual in a car. Your artificial intelligence in the car is your ChatGPT. And so ask a question. Hey, what's wrong with my car? Why is this happening? I need to get a new tire. And the car will know exactly what your tire is and can order it for you, can book an appointment at the local tire shop to replace the tire because it knows your car and it knows you. So the amount of artificial intelligence in the car is an opportunity for us to help our partners, but then also the displays in a car. When you have these cars and there's maybe 10.
So the car is not a car anymore. It's kind of adjacent a digital space in the future. Maybe it's just happening.
Exactly.
I also have a question for Mr. Liu. From your point of view in China, what's the differences in this field? 请你分享一下，从您的观察上，这个智能座舱的发展在中国有什么一些地域化的特点吗？
智能座舱我们看到的一个变化，其实它就是一种人工智能融入汽车的一种变化。刚才你讲了，汽车可能不是以前的汽车了，的确是现在，我们在人工智能领域，其实很多行业都能享受到 AI 的一个红利。就是这种 AI 的应用，那包括你讲到的 ChatGPT 类似的应用，那么这些 AI 的场景都会在汽车的座舱里面有体现。那现在我们的 AI 的技术，就是英伟达提供的 AI 技术是几乎是现代人工智能的一个底座，所以我们相信在 智能座舱这个领域里面，英伟达的解决方案，无论是我们的芯片，还是我们上面的一系列软件库，都会为在将来有更强的智能座舱的这种用户体验，带到座舱里边来，提供一个很好的技术基础。那同时，我也是觉得我们国内的这些车企在智能座舱上面的用户体验已经做到非常领先的一个地步了。
是。
那将来在这条技术路线的发展上，我们有信心应该是会持续引领。那英伟达的芯片，我们阿里在一开始提到过，我们的芯片具备更强大的算力、更强的 GPU 的能力、更强的渲染能力。那这些能力都是你将来在做智能座舱的时候一个必备的条件，加上我们丰富的软件生态，所以再加上我们在国内的一些很强的合作伙伴，我想大家会在未来看到更强的一个智能座舱。到那个时候，就真的汽车不是以前传统汽车的这种用户体验了。
So probably Ali, I also have a question for the best practice. As we just talked that in the smart EV field, we see China at least one of the leading in this field. So we see a lot of best practice here and very advanced demands, very fast requirements of the solution, the products and services. Is there any kind of best practice you think you deliver in China and can promote globally?
I think it's just the strategy that China is leading in. They literally believe that you can ship a car and improve it over the life of the car because they want to build up the size of the fleet. There's two kinds of automotive companies. One kind of automotive company, they're thinking, how many cars do I sell every year? And the day the car sells, you're almost done with it. It's like a service recall if they come back. You almost don't want the car to ever come back. You want to move on to your next car. But there's another kind of automotive company that thinks of their vehicles as fleet, like a fleet of vehicles. So how many million cars are you supporting on the road over the life of these cars? And if you notice, Apple no longer tells you how many iPhones they sell a year.
Yeah.
It's not important because they're not selling iPhones. They're managing an installed base of customers that are iPhone customers. And so they're thinking about how they can support that installed base across generations. So when you have that mindset, you actually want to ship the car as soon as possible and then make it better over time. And why? Because you're going to get data. You're going to get learning as soon as the car leaves the road. And with that data and that learning, you'll make your car better, faster. And so I think that sensibility of shipping early and learning and making yourself better, faster is a great sensibility and best practice that China does. Tesla does it. And I think that would be nice to see other customers do because long term, the quality of those cars and the capability of those cars are better.
Yeah.
Because you don't hold it for it to be perfect on the day that you sell it because you know it will never be perfect and you will constantly be making it better over the life of a car.
So as a consumer, the best strategy is wait and see for waiting for the better car.
That actually is the opposite, is that the consumer should say, hey, this is a really good car and it will get better. So I can actually buy this car because I know the car will get better. Whereas if it's the old model, you're like, well, this is a new car, but someone's going to have a new car next year and it will be better than this one. And so they might wait.
Wow,
but if a car gets better over its life, then you don't need to wait. You know this car will actually get programmed and improve over the life. You don't have to wait to buy that car.
That's the SDV era.
Exactly.
Yeah, okay. Can you share more insights about the autonomous driving future development with us?
I think there's just a lot of innovation we see, both in terms of going from level 2 to level 4 software, and the quality of software, the extent of AI in these cars is really staggering. In China, everyone is building their perception stacks using state-of-the-art occupancy perception networks or transformer networks. Whereas, in other countries, they're kind of doing traditional computer vision. And so sort of seeing advancements in AI show up in the driving stack, both in perception, in fusion, and how the car drives, the planning and control stack. I think there's a lot of innovation there. We also talked about today the cockpit and how there's so many interesting things that you can do there. And then I think that the other area where there's so much innovation is in the cloud and simulation. And we now have a simulation platform, NVIDIA's Omniverse platform, that truly is physically accurate. So we can simulate a camera, a radar, and a LiDAR, and it is exactly like a real camera, radar, and LiDAR. And the vehicle dynamics of the car is exactly like the vehicle dynamics of the car. And then you have the same computer. And so you truly can test in your digital twin and test in the real car, and it's useful. It's not like, oh, I'm showing you I'm doing this in simulation, but really you put it in the car and it's not the same. You actually benefit from this, and it speeds your development flow. So I think there's a lot of innovation there. And you're going to continue to see some really exciting things that we're going to be releasing to our customers in the cloud.
Wow, fantastic. Since we take this interview at the same time with Shanghai Auto Show, anything you want to say to your China customers?
Well, I think for us, it's just we're really proud of our customers. Our customers are building great products and services and vehicles, and it really is our pleasure to get to partner with them and help them build some really exciting products. And we hope to sort of increase that collaboration and partnership and do more partnerships with them, both in the car and the cloud in the years to come.
Yeah. Last but not least, anything you want to say to your Chinese team?
Well, I have to say, our Chinese team are sort of the standard of excellence in the automotive team. They're so aggressive. They're entrepreneurial. They don't ever want to lose. They find problems. They immediately say, hey, this isn't going well with a partner. Let's solve it. Their engagement with partners is really significant, from all levels, engineering level, product managers, executives, CEOs. So, our partnership with our customers truly is impressive. And after I was here this week, I kind of told our Chinese team, we all need to learn from you guys, because Tong has built really a world-class automotive team. And it's not just sales and biz dev, it's engineering. We have, a lot of engineers we've invested in China, because you can't support these customers from, the West. So we actually have world-class AI engineers and software engineers in China that we're building and we're investing in, because our partners are building exciting products and they need really high-quality support.
That's really high comments.
Yeah, really great.
所以我又也请刘总也回答一下这两个问题。第一个是因为我们也是上海车展同期，就有什么您想对中国的客户表达的吗？然后还有就是对中国的团队，名利的团队有什么想表达的吗？
我可能第一想说的是，中国首先给了我们一个非常好的土壤，就是我们国内这些电动车企能这么的热爱自动驾驶这个方向，对人工智能有这么强的一个热情，对我们这种人工智能的底座企业来说，那我们肯定是相当幸运的。我们有一个非常好的市场，能让我们的这个技术发挥得出来。第二呢，就是我们的技术的确是能够为我们国内的车企提供一个非常好的平台，这个也是我在过去2-3年非常强的一个体验，就是我们把在人工智能领域积累下来的这些技术储备，能够非常好的用到汽车领域来，无论是做自动驾驶还是做智能座舱，这个也是我们感觉到很激动，机会在我们面前，然后我们手里有足够多的这种工具可以去赋能给我们这些用户，这是总体来说，我个人觉得对我们公司对中国这个市场来说，能有什么价值？那当然我们在中国的未来能做一些什么？因为机会很多，然后我们在技术创新上，就是刚才阿里也讲过，会为中国打造很多适应于我们本地需求的方案。因为中国的智能驾驶和自动驾驶是发展速度相对最快的，
是。
那么我们的产品战略一定会更加适应于我们本地的发展。这个是我们非常感谢公司对 中国有非常强的一个战略倾向性，要为我们打造出来更合适中国能满足中国市场发展
要做得很好，
本地化的适合中国市场需求的这种解决方案。大家也会看到我们有一系列的产品能够推向市场。那第二呢，我们要非常强调这个 localize 不仅仅是产品本身 localize， 我们的本地团队如何更好的去支持我们的用户，这个是我们要花心思去想的。那我们的技术团队在不断的增加人力，在扩展我们的技术支持力量。另外一方面，我们也是非常拥抱生态合作伙伴的，这只有生态才能帮助我们自动驾驶、智能座舱这个行业高速的发展，绝不是只靠我们自己这一家公司可以做得出来的。因为这个方向潜力太大，机会也特别多。就是刚才我们讲的汽车，它是一个有机的生命体了以后，也就是我们原来讲的汽车刚，你以前传统汽车你买的时候就是最佳状态、最新的，
买完就结束了，
买完了以后就越来越差，
折旧了。
对，折旧了。现在我们的车是希望你越开越新，越开越兴奋，因为它就像一个小孩一样，成长的越来越给你带来惊喜，这是软件定义的魅力。
是，
所以我们是希望有更强的本地合作伙伴，能够助力这个行业的不断的向上去发展，让我们的技术变得越来越新，能够给用户带来越来越好的体验。对，
好，谢谢刘总 ，Thank you, Ali.
Thank you.
Thank you to accept our interview. I wish NVIDIA a great success in China market.
Thank you so much.
谢谢。
谢谢。Thank you.
Thank you. 谢谢。
谢谢。